So before I tell you exactly about PyKX and what it is, I'm going to tell you a little bit about the predecessors that it had, because I can only see further by standing on the shoulders of giants, or whatever that quote is. So beforehand we had PyQ, which was basically a queue process emulating Python. So it's this queue process that, for all intents and purposes, has a Python interpreter built on top of it, and it can run Python code. However, it's got a special binary to do that, so you can't actually run your usual Python binaries. And crucially, it's really difficult to work with lots of the stuff on PyPy, so you can't actually pull and use stuff from the developer portals, which is really what makes Python powerful and interesting in the first place, I think. So then came QPython, which is a vanilla Python library. Great, you can install all the libraries you want from PyPy, that's cool. But it's essentially just a Python Q client, so it's just a Python process that links up with Q, and you can send queries to it and pull them back in. And kind of part of the problem with that is that everything over the wire, because it talks to Q via IPC, so everything over the wire gets deserialized back into Python interpretable objects, which is, as you can imagine, kind of expensive when you're pulling back large amounts of data. You have to then do all of the work to make them make sense in Python. So there's no shared memory space in QPython, so it's really just a client. And then kind of lastly, and probably most significantly, came EmbedPy, which was really a solution to provide sort of the Python infrastructure and the Python library and language in Q. So you ended up being able to write what I would call sort of a weird DSL that is Python that works in Q, but it looks a lot more like Q code than Python code. And you can also run sort of a version of Python in EmbedPy as well. And it addresses the shared memory space problem, so you can reference objects in Python and Q and sort of swap them between. And it's got fairly good conversion for doing that, but it's rather limited in what types it can actually convert to and from, etc. Also, I mean, crucially, if I haven't made this point, it's Q first. It was developed to help Q developers integrate with Python functionality, not Python developers to integrate with Q functionality. And so I think that is crucially where PyKX kind of comes into the picture. So it's entirely a Python first API. So you start a Python shell, you import a library, hopefully I'll show you in a second. You import a library and you have basically Q functionality in your Python shell. You don't need a separate Q process running. You don't need anything else. You just need a Python shell with this library and a license, obviously. And you can start writing Q as you would in a regular Q process. You can pull it back into pandas. You can pull it into NumPy. You can even pull it into PyArrow. So it does Parquet and stuff as well. It's got very fast type conversions. A lot of times zero copy. So we actually just repoint a pointer somewhere, which is pretty neat. And yeah, the primary use cases we imagine are data scientists and quants who are building ML models and visualizations, who maybe already have Q in their stack and they have Python in their stack, and they're sort of swapping between them. This makes their life a lot easier. Again, anything with an integration with Q and Python sitting around, it just makes the interoperability of those two far easier. And my kind of little gem, I think, that PyKX will solve is just speeding up analytics and batch processing. I mean, if you just drop this in, there's a chance that it speeds up any big batch processes that you have, especially if they're running single-threaded, which they shouldn't be, but if they were, it just speeds them up very quickly for no real extra cost. So hopefully I've at least convinced you or got you a little bit hyped about what PyKX is and what it's trying to do and what we're trying to achieve with it. And now I will show you a demo. Now, caveat is that my demo is running on an Azure cluster, which I can't access from this internet here. So it's going to be sort of frozen in time, but I have a little interpreter at the side as well that we can kind of go back and forth in if we have any questions or anyone wants to see anything. Again, slower. I also am assuming that most of you guys know Q or won't be too perturbed by seeing too much Q code. It's more like showing you the different ways you can do things in Python and Q and port them between each other. So with that, here is my notebook. Is that okay? Can everyone see that? If you can't see it, stay very silent. No one can see it, obviously. Okay, so yeah, so we've just got an imports at the top. So the key thing is here, PyKX has KX. So that is where all the magic lives. And then most of what I'm going to try and show you here is speed of conversions initially, and just the ability to swap things in and out of the two memory spaces without really any consideration. So first thing, create a data frame. It's fairly simple. Set in the Q memory space a variable called T1 to the value of the data frame. And then I just go through a bunch of equivalency checks here to make sure they're the same. So the way that the syntax works is that I can use things like equals here as a function. I mean, since it is a function in Q, and it automatically expects a couple of arguments in here when I call it like this. So I can pass in my table from Q and my data frame and verify they're equal. They are. I can parse my data frame into Q and then verify it's equal in the Python memory space, if that makes sense. So not going into Q at all, just purely in Python, but representing this object with a Q byte stream, basically. And then lastly, I can check the match. And again, I can kind of do this weird hybrid version of the world where I'm doing T1 matches, and that's obviously a projection in Q. And then I pass in a variable, which is df, which gets converted into the Q object and then compared. And they're all true, so they're equivalent. Everything there parses back and forth and is the same structure for all intents and purposes. I'm going down here, just doing a little flipping, because if we do Q, we like to flip. And you could probably achieve what I've done here fairly easily without flipping, but why not? I wanted to kind of show the difference between writing a query in Q and sort of the terseness and relative sort of, it's fairly verbose. You're flipping T1, you're valuing that flip, you're flipping that again, you're then, it makes sense when you write Q, I think. Versus in pandas where you write, this big sort of verbose block of text to achieve the exact same thing. And again, verify that they're equal using the match operator. So use the match operator. Again, you can pull that directly into Python and then call it on whatever arguments you have. So hopefully you're starting to see this switch in between Q and Python memory space is fairly easy to do. You can expose functions straight out of Q and operate from Python with those functions. So it's very, very powerful because you have this shared memory space. So again, the next thing I'm doing, and I'm purely doing this just to nerd out. Like someone gives me a thing and goes, this is related to Q. I immediately go, well, how fast is it? Because that's what Q is known for. So generate, 100 million floats. It took 232 milliseconds. And when we do the same thing in NumPy, which is this bit here, it took a fairly slow 648 milliseconds, if I do say so. I think that is quite significant, right? That's a 3 times speed up roughly for no reason. So if you start to expose that, if you're doing Monte Carlo sims and you need a whole bunch of numbers generated randomly, maybe that is significant. That's 3 times speed up for basically having this drop-in number generator. So that to me makes sense. The other thing that I do here is do a quick set. So when I do a set here, that copies obviously the data structure here, which is in NumPy, and copies it into Q. And it takes 71 milliseconds to do that, right? 100 million floats. You don't need to remember that it takes this amount. By the way, this is also on an Azure cluster with like infinite compute, so it might even be, much quicker than your home laptop, or I'd hope it would be. But I think kind of what I'm kind of getting at here is that if we cast a NumPy float 64 to an int, in NumPy alone, it's X. It's slow. If we do it with only swapping out the Q data structure, so we're just then referencing A and Q, which is the variable name I've set in Q, doing exactly the same operation as we did in NumPy, and it immediately halves it. I mean, for doing nothing. You're literally just swapping some tiny bits of syntax. To cast a Q float into an int is, again, a little bit smaller. And if you do it entirely in PyKX or in Q through PyKX, it's 33 milliseconds to do it with nothing else, which is like a factor of 10 faster. And repointing at the end here, we just take that variable out we called C here, which is the structure of that array, if you want, in Q memory, and we just repoint it, so it's actually being set. Here we set it in Python memory, and we're going to just set it now in Q memory, and that takes 8.4 microseconds. That's like lightning quick, because again, all it's doing is just pointing to the new data structure. It's not doing any copy. There's just a point to a new data structure. So again, that hopefully illustrates the ability of PyKX to copy data types from and to these two memory spaces with fairly much, a lot of ease and really, really high performance. And it'll probably get better as we continue to work on it, to be honest, which I find pretty exciting. Here we've got a couple of different representations of what we can parse into. So I set S earlier. Up here it's just a little tiny table. We have a PyKX table. We have a data frame that we can pull out with .pd. We've got a PyArrow table that we can pull out with .pa. We've got a NumPy array that we can pull out with NP, and we've got a dictionary you can pull out. So we can pull out all of these native Python structures and even different libraries in Python through the API fairly painlessly. We also support, this is also just going to keep going like this. I'm just going to be like, this is also a feature, and this is also a feature. We put in cell magic recently, so we also have a Q console. You can drop straight into a Q console from Python, but we have Q cell magic, which is you just do a little double %Q, and you're suddenly in Python, or you're suddenly in Q, sorry. And we just do various Q things in here. I just wanted to make like a fun shape, so I just made a big pyramid because that's what I do whenever someone gives me Q. And yeah, retrieval again doesn't take any time at all. Again, it's just repointing. So that's all that I'm trying to emphasize here. So that was that 2D sim list, this thing. It's easy to integrate structures, so we can just pull stuff straight back into Py and interrogate it and sort of make sense of it. So people coming from a background of Python but not Q have a way better chance of understanding, and maybe some people who have a Q background as well have a better chance of understanding what shape the data structure's in, or what this sort of underlying structure looks like. And this is particularly obvious in this next point, where I did a sort of an X join each left, each right by 10, which is again another kind of classic thing to do. And in Q it looks like that, which tells you nothing about its structure. But if you pull it into Python, you can immediately start to say, oh, okay, that's a list of lists that are 10 long and each has 2 elements. Okay, that makes a bit more sense. And that's a fairly easy thing to do and to help you understand sort of what data structure you're working with, which I find kind of helpful personally. Because I think that you end up interrogating Q quite a long time trying to figure out similar things. I'm not going to spend very long talking about this thing, but you can call Python inside Q. So I've created a little class here called A. I initialize A and assign its function into the Q namespace. And then I just verify that they're the same. And they are. Look at that. Amazing. Who would have thought? I mean, hopefully you guys would have thought now.
That's really, really useful though, for like using all the Python stuff inside Q.
Yeah, exactly. Yeah. I mean, I am excited. I'm not. I think it's a very cool thing. So the query interface is another really cool thing. As Owen mentioned before, we have ANSI SQL support now. Obviously, we have pandas type support, and we have regular old Q SQL and Q functional selects and stuff. All of that's built in here in various different shapes. So we've got a SQL thing here. We can query it. I've set this new variable A. Keep up with my variable names, by the way, they're terrible. It's just A is just a table, okay? That's all you need to worry about. I set it into the Q memory space and then do a query. That's all there. And you can pull that data frame or leave it into Q, it doesn't really matter. I think the kind of interesting thing here is that when we time a QSQL execute, which has a nice, by the way, API where we have a where statement and we have a column, we can do that in 2.3 seconds or milliseconds versus the equivalent in pandas. And I think this is the equivalent in pandas. And if anyone thinks that I've done this wrong, they can find me afterwards and tell me. But that is the sort of same thing to do when you're dealing with times, which is a little bit more difficult in pandas. And it takes like 40 milliseconds. I mean, that's 40 milliseconds. Come on. Okay, just me. So we've also got the SQL engine. So you can just do this QSQL stuff. The ANSI SQL stuff. It's not super performant to do it because it's got to parse it into Q first in order to do it, but it's there. It gives you a really good first place to swap in this library if you want. However, running a functional QSelect is like lightning quick, as you would expect. It's 13.8 microseconds, which is a factor of like, what, 10, 80, let's say 80, thereabouts. So hopefully I have about a couple of minutes left. I'm not going to go on too long because it's just going to be me showing you, like, look how fast it is. Have you guys seen how fast it is? Because I think that's a real big selling point to this. You can just drop it in and it just goes faster than the equivalent SQL statement or the equivalent pandas statement. You just drop it in and it's better. Right, quickly going on because I don't want to eat up too much more time is we have a context interface. So again, if you're in Q land, you have lots of different variables. So like .q.s here, you can access directly off of the Q object and call stuff on it. You can also use a Python context type thing to call like s directly in this case. So .q.s from the global namespace, or in this case, you've changed into the Q namespace and you're just running s because that's available in that namespace. And you have the ability to do timestamps and stuff in here. One other little thing that I decided to do, because we're in Python, is just plot some random stuff. So I created what do you call it, an x squared with a little bit of noise on it. Plotted that in this much code. I don't know about you guys, but if you're dealing with Python, you're playing around with plots. The plotting libraries are kind of esoteric. NumPy can be particularly esoteric when you're trying to pull out numbers that do something. You're like, I want a Gaussian distribution. You're like, okay, how do I do that in NumPy again? Whereas in Q, I think maybe it's just me, but it is a little bit more intuitive. We can call NumPy on PyKX objects, so Q objects, we can call NumPy directly. It does come at the minute with this lovely warning saying, we don't support this, but we will soon, and it does work well enough, so it's available. Yeah, and then the only other thing I want to show you is the IPC. So PyKX can also function as a client for Q. So, is that very, very small? I'm going to make it bigger anyway, and hope that my window manager resizes things, and it will. Wow, amazing. And this one. So I've got a Q process running on port 1979. Why not? Great year. In my other terminal here, I've got a Python thing running, Python shell running with PyKX imported as KX. And I can make a connection to my local host on the port 1979 as Q. And then I can do a whole bunch of stuff, which I will show you now. So fairly straightforward stuff, by the way. It's just to show you where, for instance, functions are actually called, because you can pull a whole function across from the remote process and then store it in your local memory space and then call it, and the remote function never gets called. Or equally, you can call the remote function and it'll register there. So that's what that does, and I'll walk you through it now, and then I'll probably wrap up because I'm conscious I've been talking for a little bit of time. So first thing we did was set was called equals to false, and over here I've got was called is true whenever this function is called, just to make sure that we know, if it was called. So if I run was called in here, if I could type, it is called. Oh, it wasn't meant to, it does do that, okay. So we show hello world, which just pops up here. We print qfunc on 10. At that point, it was not called. Then we print the was called, 0b. Then we pull the function across into this memory space, and we call f. Again, it wasn't called when we called it. And then finally, we address it via the context. So we go directly across the handle, pass 10 in, and then we have it was called in the local space. So that's just a portion of what you can do with the queue connection. We have an async mode, which you can pass something like wait false, I think, and it will execute all of this and not wait. So I've got some bits and pieces back, but it really, if you have a long query, you can just let it run and come back and pick it up later, which is what you can do in most normal queue processes. So that is really the majority of what I wanted to show you. Hopefully I haven't taken up too much time. There is some needless plotting, but that's just because I can do that in Python. So yeah, I think that's probably it, and I will open it up for any questions.